Hi, everyone. Welcome to another episode of the Data Standard Audio Experience. We have another exciting guest. We have Alexis Yelton, the head of data science at ActZero. And today we're going to be speaking about how to detect cybersecurity attacks using ML. So welcome to the show, Alexis. I'm so excited to speak with you and learn more about this.
Yeah, thanks for having me. It's great to be here.
Yeah, absolutely. Let's get started. Can you tell us more about yourself and just maybe how that led you to your work today?
I'm the head of data science at ActZero, which is a cybersecurity startup that uses novel machine learning approaches to detect cyber attacks. We're a managed detection and response company, which is an MDR. And that means that we work with clients to provide them with an outsourced security team to detect and respond to attacks. And we work with businesses with 150 to 3,500 employees. How I got here from where I was is a bit of a meandering path, I guess. I originally had a PhD in bioinformatics. Then I was interested in industry, so moved into data science. And I've worked in a number of different areas in data science, including natural language processing and ad optimization, and started working in cybersecurity recently. But I actually think it's a really wonderful area for data science, and we'll talk about lots of the reasons today.
Yeah, cybersecurity in general is a huge booming field. Everyone's getting into it. And a lot of companies are taking measures in terms of just cybersecurity attacks, ways to detect it. And so why should we be interested in ML for cybersecurity?
Yes, it's I think a super important field right now in the data science space. First of all of us have heard about these prominent cyber attacks in the news. For instance, like the SolarWinds hack resulted in breaches at some pretty important government and industry targets. But cyber attacks are growing more and more common. Smaller businesses and large operations are all having to deal with them now. And ransomware in particular has become quite professionalized. So what I mean by that is you don't even have to be a programmer now to launch a ransomware attack. You can go into the dark web and you can buy ransomware as a service just so that you can make money off of exploiting companies or people. So a lot of smaller businesses have had their data held for ransom over the past few years. And ActZero aims to sort of bring our advanced cybersecurity services that include ML and also expert security analysts to the businesses to stop these kind of breaches. And I think the ML that we're developing in particular is an important tool for stopping attacks because it's flexible. And historically, a lot of the detections that were built for cyber threats were based on rules or looking for known malware in online databases. And even now, there are many detections that are still based on these principles, which make your systems really vulnerable to easy evasion. And ML adds to this. It provides more flexibility in detection, and it generally can detect a wider range of attack types and provide more protection.
Yeah, awesome explanation there. And that's super scary to hear that you can buy ransomware, you can buy almost services to hack a company, just hack their security system. That's terrifying, but that's awesome that there's people like you that are able to mitigate this and kind of work this out to kind of detect it before it actually occurs. And so what is it like managing a data science team that goes beyond machine learning to detect and mitigate cyber attacks? Can you talk more about that?
Yeah, I think so. My team focuses on detecting cyber attacks before they can cause damage. But I'm a big proponent in running this team and using domain knowledge in conjunction with data science. So cybersecurity is a very interesting area for domain knowledge in that most people don't have that much domain knowledge about cybersecurity, including myself when I first started working in this area. So coming into cybersecurity, I had a fair amount of experience in data science, and I knew what ransomware was, I knew what malware was, but I definitely couldn't tell you how it worked or what an attack might look like on a machine or surface. So what that means is that we work very closely with experts at our company. We have both security analysts whose focus is looking at the output of our models, determining what output is actually attacks and responding to those attacks for our customers. And then security engineers who are experts at creating synthetic attacks, know about the history of cybersecurity, and are experts in detection. So both of these teams give us ideas of what attacks to focus on and what to look for in attacks. And the security engineers in particular are embedded in the data science team, more or less. We meet every day, we work on all of our projects together. So that's a really great way for the data scientists to gain the domain knowledge they need, and for the models to include the domain knowledge that it should. But we complement what the work that those teams are doing by using data to come up with data-driven features, deciding what algorithms to use, and come up with good models for detecting attacks.
That's awesome. And so I kind of just want to hear more about the process of detecting cyber attacks. Can you kind of walk us through that process? Are you checking for continuous past patterns of attacks? Is there data? Is it openly available, like for your company to kind of work with? How does it all work?
Yes. So most of our work depends on looking at historical data, most of which is data from our customers. And we often are building anomaly detection models that use this past data to establish basically a baseline. What's normal? What does normal activity look like? And then we try to train our models to detect very unusual activity to bring to the attention of our security analysts. However, sometimes we have a lot of attacks available to us in our data set. In those cases, we can train supervised models that specifically look for attacks that look like ones we're familiar with. In general, I prefer to combine these methods to get the best of both worlds. So with anomaly detection, you get an ability to detect new attacks. And with supervised models, you get a really strong signal as to what's an attack. One thing that's very important for our company's mission is to have very high fidelity detections. What that means is we want our detections to be high recall. We find most or all of the attacks that we know of and not have a lot of false positives. And that second part is a bit unusual in the industry, and it's really important. And the reason for this is because the status quo is sending a lot of alerts. So you can imagine you get security alerts probably on your Gmail, right? If you log in from a new device, you get an alert. If you're a security analyst or an IT admin at a company, whoever's handling the security for that company, that means getting it from these alerts from everyone in the company, which can amount to hundreds or even thousands of alerts per day. And that results in something called alert fatigue. And that's where when you are going through that many alerts, you will miss ones that are actual attacks. And in fact, there have been some high profile breaches in the United States in the past couple years in which big enterprises have lost hundreds of millions of dollars from attacks that were actually detected, but where the admins or analysts who were looking at it did nothing. So we really strive to reduce those false positives to prevent that from happening.
Yeah, and that's a great perspective that you were able to give to our viewers about just kind of that process of detecting these cyber attacks. So you talked about kind of analyzing these past continuous problems within data sets that you probably already have. What do you do in the case where if you don't have the necessary data to kind of analyze these past patterns? Because in that case, you still have to detect somehow, but what do you do if you don't have the necessary data?
Yeah, so this is something that comes up fairly frequently because cyber attacks can be few and far between. And in fact, like our whole business model is to reduce the number of attacks and reduce how far they get into our client systems. So that actually is removing data that we need to build models. So we're sort of shooting ourselves in the foot, but that's a good thing. So we have developed some ways to source attack data that doesn't come from our customers. So the most obvious one is we use publicly available data. For some types of attacks, this is very possible. There's lots of publicly available data. And for other types of attacks, this is a very difficult thing to do. So in those cases, we create synthetic data. And this can be tricky since we need to make sure that we create a broad spectrum of types of attacks to prevent adding bias to our detections. But we can do this in concert, working with the security engineering team. And then most importantly, we have a really strong emphasis on learning from the data after models have been deployed. So we have a human in the loop process for this, where we gather human labels for the output of our models as they come in, any attacks that are identified in other ways, and then continuously improve our models over time. And we do that by simply, first of all, retraining our models very frequently. So whenever we have new data, we can retrain our models and make them better. And we also do it manually. We use the data science knowledge that we have to add features, change algorithms to make them more appropriate for the new data that we get.
Yeah, absolutely. Great insight and great explanation there also. So we know that being in the technology field, data science field, anything like that, things are constantly changing and evolving over time. The problems that we have today will be solved within the next probably 5 to 10 years, but then we'll have another set of new problems that we'll have to deal with, and the cycle kind of continues. How do you constantly adapt and change with all of these cyber attacks that are coming up?
Yeah, this is actually the funnest part about cybersecurity data science for me. Unlike many other types of ML, like natural language processing or image recognition, our data is changing very frequently, and it's changing, I believe, more. So some of that has to do with hackers and cyber attacks, and some of it does not. Firstly, our customers might install new software, hire new IT admins. They could have software updates, scripting languages change and incorporate new commands. All those things will change our data. But in addition to that, the hackers themselves are constantly trying to change their attacks to evade detection. So we have a bit of an arms race going on. We detect something well, the hackers will try and change. Hackers even use software specially designed to test small changes in attacks against antivirus or endpoint detection software until they find attacks that can evade those approaches. Another good example is what's happened with malware over the past decade. So most cyber attacks are based off of malware, so files that execute on your system and then do something malicious. But more and more over the past decade, there have been a growth in living off the land attacks. So living off the land attacks make use of software that you have natively installed on your operating system, and they run commands in memory. So they never create or run a file on your system. So that means they can completely evade antivirus detection because antiviruses evaluate files for maliciousness. So ActZero has a bit of an advantage over using an antivirus system alone. We can complement that by looking for one behavior as opposed to looking at the files themselves. So that allows us to look at behavior of malicious files or behavior in living off the land attacks. Additionally, we really address how attackers are evolving over time with our ML. Our models are based on features that are intrinsic to as broad a spectrum of attacks as possible. So we could also say that we use features that are fundamental to attack success. So I can give you a good example. So one of our ransomware detection methods looks at the number of file changes per second as a feature, a type of feature. And because ransomware works by encrypting as many files as possible on a machine, it's really hard to avoid making many file changes in a short period of time. To do so, the ransomware author would have to do something like encrypt files very slowly, which of course they can do, but it makes it really easy for the victim to recover their files or to detect the attack if they're doing that. So intrinsically, this attack involves the features that we're looking for. We also, as I mentioned earlier, have a really strong emphasis on anomaly detection. So that allows us to detect attacks that really don't look very much like previous attacks, new types of attacks, because not only are they different from past attacks, they're also super different from normal behavior. Usually attacks look very different from normal behavior.
Right. And thank you so much for just explaining everything to our viewers. I think this is something that a lot of companies need to really emphasize on, just the importance of security within your company. So thank you so much for talking more about your company and what you do. And thank you for detecting all of the cyber attacks before they actually occur. Thank you so much for being on the show. We at the Data Standard, we're trying to build a community of data enthusiasts and data thought leaders in order for everyone to have a space where they can collaborate and network with each other. So what is something the community can do for you?
We're definitely interested in networking opportunities, particularly partnerships in the cybersecurity space. And certainly if your company needs to hire someone to do your security, we're available.
Absolutely. And where can our community find you online?
Feel free to contact me at Alexis Yelton on LinkedIn. Also, please look at our website. It's ActZero.ai.
To our viewers, for more information on the Data Standard, you can find us on many different media sites such as YouTube, LinkedIn, and also our website at www.datastandard.io. And this episode is sponsored by Pandio. They're innovating the tech space with their Apache Pulsar messaging system. You can find them at pandio.com. So thank you so much, Alexis, for joining us. Great speaking to you and just learning more about the cybersecurity space in general.
Yeah, thank you.